As we said in the last video, what we're going to need to do for this Monte Carlo simulation is to determine whether or not points, or darts, are inside an arc or not. So to get there, we have to take this detour through what are called Boolean expressions. When we want to make decisions in our computer programs, we generally ask yes or no questions, like, hey, is this dart inside the arc? And that will be either, yeah, it is, or no, it's not, yes or no. So the answers to those questions are Boolean. It's named after George Boole, who was a mathematician. That is, the answer is either true or false. So Booleans are actually another primitive type in Python, just like integers and floating point numbers, except the only values for a Boolean are true or false. So with integers, right, we can have really any integer we want. In a Boolean, there's just two values. It's either true or false. And we most frequently get Booleans, from what are called relational expressions, and those involve relational operators that look like this. We have the less than operator, less than or equal to, is equal to. Now that one's going to get us, right, because it's two equal signs right next to each other. That's different from assignment. It just means is equal to. Greater than or equal to, greater than, and not equal to. So let's look at session 2.9 and see some of those in action. Here in 2.9, what we do is, first of all, create a variable called dog weight and give it a value of 25, and then I have a series of expressions. So this one is a Boolean expression, and again, a relational expression that will produce a Boolean. Note that it uses two equal signs right together, no spaces. So this should get true or return true. And it does, because dog weight is equal to 25. The expression dog weight is not equal to 25. That should evaluate to false, because it is. Dog weight less than 25 is also false. Dog weight less than or equal to 25, that will be true. Dog weight greater than 25, false. Dog weight greater than or equal to 25, true. And notice that we can use expressions here as well. So dog weight is equal to 5 times a 5. That means this expression would get evaluated first, and then we do the comparison, and that's true. Okay? We can also compare two variables. So if I set cat weight equal to 18, that's a big cat. Anyway, then we can ask this question, is dog weight equal to cat weight? And the answer is false. Okay? Now we can also put those together into compound Boolean expressions via logical operators, and that works like this. Okay? Compound Boolean expressions are simple Boolean expressions that we connect together with logical operators, and, or not. And those logical operators, it's easier to understand those if we look at what are called truth tables, which are on the next several slides. So if we're doing and, then we have two Boolean expressions, x and y. If x is false and y is false, x and y is false. Okay? If x is true, y is false, the result of x and y is false. And if x is false, y is true, the result of x and y is false. The only way to get a true value out of x and y is if both x and y are true. Okay? An or means it's true if either or both of these are true. So the only place where x or y is false is when both the values of x and y are false. In every other instance, at least one of them is true, so the whole expression is true. And then not simply returns the opposite. So if x is false, not x is true. If x is true, not x is false. Okay, now let's take a look at some of these. 6 is less than 10 and 3 is not equal to 5. What do you think? Well, that one should be true because both of those are true. How about this? 6 is less than 10 and 3 is equal to 5. That's false because 3 is not equal to 5. 6 is less than 10 or 3 is equal to 5. That's true because 6 is less than 10 is true. And 6 is greater than 10 or 3 is equal to 5. That'll be false because both of those are false. Now, Python does what's called short circuit evaluation of compound booleans. And what that means is it stops evaluating an expression as soon as it knows the answer. So in this situation, 6 is less than 10 or 3 is equal to 5. Since it's an or and the first part is true, then the overall expression is true. So it quits right there. Okay? And that will become important in certain sort of obscure instances later on, but we'll take a look at those as we go. Okay, and then session 2.10 would have more examples there. Let's take a look at that real quick. Okay, and again, this is just sort of the similar idea. 6 is less than 10 and 3 is less than 7. That's true. 6 is less than 10 and 10 is less than 6. False. 4 is not equal to 4 or 5 is less than 8. True. 4 is not equal to 4 or 8 is less than 5. False. Now, nots get a little crazy. They're hard to understand, but not 6 is less than 10. Well, 6 is less than 10 is true, so not true would give us a false. And not 6 greater than 10 should be true. All right, now we're ready to move into the next part, which would be where we would talk about if statements, and that's the third part of the chapter.